But once I want the problem to have a solution, I must extend the number system. And the upshot of that whole thing is that we now invent something called the complex number system. First of all, the complex numbers are defined to be the set of all symbols, let's just call them symbols for the time being, all symbols of the form x plus iy, where x and y are real numbers, and just to refresh our memories here, I is the symbol which numerically represents the square root of -1. Okay? Notice that the x and the y are real numbers, though, where by real we mean what? Their squares are non-negative. Now, you will recall that in any mathematical system, the thing that you're dealing with is more than a set of numbers. It's a set of numbers or a set of objects together with a structure, certain rules that tell us how to work with these elements that make up the set. Remember, the difference between a set and a system is a set is just a collection of objects. The system is the collection of objects together with how we combine these objects to form similar objects, etc. And what is the structure in this case? Given the two complex numbers x1 plus iy1 and x2 plus iy2, we define equality to be sort of component by component. The real parts, x1 and x2, must be equal, and the imaginary parts, and by the way, just a word of caution here, the imaginary part of a complex number is by definition the coefficient of I. Notice that the imaginary part is itself a real number. The coefficient of I is the real number y1. What we're saying is we define the definition of equality for complex numbers to be that two complex numbers are equal if and only if their real parts are equal and their imaginary parts are equal. Secondly, we agree to add two complex numbers, component by component, so to speak. In other words, to add two complex numbers, we add the two real parts and we add the two imaginary parts. Okay? That's all this says. And thirdly, to multiply a complex number by a real number, we multiply the real part by the given real number and the imaginary part by the given real number, which is what this third rule says. And all I want you to see from this is that by the very definition of these three structural properties, we have made the complex numbers a two-dimensional vector space. In other words, it means that we can now visualize the complex numbers geometrically in the same way that we could visualize the real numbers geometrically.